All right, proving parallelograms using coordinate proofs. So let's see what we're up to here. All right, we're asked to write a coordinate proof of this statement. If a quadrilateral is a parallelogram, then opposite sides are congruent. Well, we know that that's one of the theorems of a parallelogram. Let's see, we got that down as theorem 6.9. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, well, let's just go about writing this as a coordinate proof. If ABCD is a parallelogram, that's our given. And then we're asked to prove then, if that's true, the opposite sides. We'd be asked to prove that AB is congruent to DC and AD is congruent to BC. And we've got some values here. Let's see, A is at 0, 0. It's at the origin. And then B is at A, comma 0. C is at B plus A, comma C. And D is at B, comma C. Okay. Well, let's set about. We're going to use our distance formula to prove that. So first, let's go about looking at AB. So AB then is equal to the square root of A minus 0 squared plus 0 minus 0 squared. And, well, that's just going to end up being A squared, square root of A squared, or just A. How about DC? Well, let's see. DC then is going to be B plus A minus B squared. And then we got C minus C squared, which of course is just going to be 0. And the B and the B, negative B, are going to cancel. It's just going to leave us with A squared, or again, this just square root of A squared is A. So AB and DC are congruent. All right, well, how about AD and BC? Let's start with AD. All right, so here we got AD, and so then let's see, let's change colors. So we got C minus 0 squared plus B minus 0 squared. Okay, let's see, what is that going to leave us? That's going to leave us with the square root of C squared plus B squared right there. All right, well, how about BC? All right, BC. So BC then is going to be A minus B plus A squared. And this is going to make that a negative B and a negative A. And so the A and the negative A are going to cancel, just going to leave us with negative B squared. But negative B squared is B squared. And then we've got C minus 0 squared, which is just going to leave us with C squared. So we would have B squared plus C squared, square root of that. But really, I can switch that around. And there I got C squared plus B squared. So AD and BC also equal each other. So since AB, which is A, equals DC, which is also A, and AD, which the distance of that is the square root of C squared plus B squared, equals BC, which that distance is also the square root of c squared plus b squared, then segment AB is congruent to DC, and segment AD is congruent to BC,